Okay, but like, so the instructions, make sure that we're recording. That would be good. That would be a good start. And so
Yeah.
the second thing that we're supposed to focus on in these group meetings is that we're discussing problems that we're having, like specific things that we're having trouble understanding.
Yeah.
And then we go over the function compare worksheet, compare our answers to the key, which is underneath that.
Okay.
So let's look at this. The answer key. Okay, looks like they changed that first column. What did it say? Function is what it was called.
Yeah. First column is function.
Yeah. So it looks like. I don't even know what that means. On the answer key, that first column is called symbolic, but it looks like they just put the. It looks like they just put the parent function. So for linear, in the first column, it looks like it would just be like the default formula, like y equals mx plus b.
Okay.
And then for data, you've got like the constant first difference where the change in y is always the same. So like if the x goes from 1 to 2, y goes from 2 to 4, you know
Yeah.
that x is going to go from 2 to 3, and then y is going to go from 4 to 6.
Okay.
That makes sense. And then the application is kind of like whatever would be like a linear thing. Like the example that they gave is driving at a constant speed.
Yeah.
You got like distance over time, and it's just straight line.
Yeah. Okay. So okay, what about absolute value?
So absolute value, if I remember correctly, you've got like so absolute value, the function looks like a y equals x, but
So y equals the absolute value of x.
Yeah, pretty much.
Okay.
So on this real quick. So you got like your graph, right?
Yeah.
The graph for absolute value kind of looks like a V, like that.
Okay.
And I don't know if you remember back to when we did the air hockey lab.
Yeah.
That would be kind of like an absolute value application, because it like goes out and then it like bounces off and travels back. And so that's kind of like what the data does. It's got that constant first difference until it hits the bottom or the top, I guess it's going the other way, and then it just comes back up.
Yeah. Okay, quadratic.
So we've got.
What was the x squared plus x plus whatever?
Yeah. Yeah. So you got like, yeah, pretty much like that, and then that makes like the parabola shape. It's that U shape. And that one's a constant second difference.
Okay, and what would you say the application would be on that?
You drop something, things that are falling. Yeah, if you threw something up in the air, it comes back down. Like say
Okay.
if you hit like a golf ball, it flies up in the air and comes back down. Like basketball.
Okay.
And then we got our root functions.
Okay.
And that was kind of like comes like up and out. You probably see
Okay.
in the data.
So how would you write the function for that?
That'd be like y equals square root of x.
Okay.
And that's kind of like the the root function is kind of how we see like what we saw with the pendulum lab.
Okay.
And then I was kind of confused with the data for this one. It says decreasing differences with starting point. So it shows us the table where x is 0, y is 0, where x is 1, y is 1, where x is 2, y is like 1.4, x is 3, y is 1.7. So it kind of like tapers off, kind of how we saw in the graph.
Mm-hmm.
So I guess, does that make sense?
Yeah. Kind of.
I feel like it's just like a lot of stuff that needs to be learned. I feel like it's not.
I don't like doing math online.
Yeah, I don't feel like it's set up super well. Although I don't think
No.
I should be saying in our online group that our teachers are gonna watch.
Okay. So should we go over the questions real quick?
Yeah.
Okay. So which functions have x to the power, including fraction powers? So the first one would be quadratic, right? That's the only one that has powers, right?
Yeah, I would think so. Which functions have x to a power? Just quadratic, right? As far as we know. Cool. Yeah. Quadratic as well. Which functions require a fraction as part of their symbolic expression? I don't think we have any of those yet. Like a y equals 1 over x or x over something. I think we don't have those yet.
I don't know, maybe a linear.
For number 2,
What do you think?
we don't. I'm just like looking at the table that we have. Aside
Yeah,
from
none of them really have a fraction,
I think what
right?
number 2 is asking is because it's which function require a fraction. We don't have any of those. That would be like a y equals 1 over x.
Yeah.
That makes sense. I don't think we have them. And then number 3 looks like it'll be absolute value because it's got those unique like double line things around the x, the absolute value.
Mm.
And it gives away what function it's talking about there. What do you think for number 4?
For which functions will one of the differences the data first, second, or third difference be constant value? Well, the only function up there that has 3 parts to it is quadratic, isn't it?
Yeah, it's the quadratic has the second differences, right?
Yes, I think so. First, second, or third difference be a constant value. Wait, but it's asking for a constant value. The more of a constant function is linear, but quadratic has those parts.
You're supposed to list the function and which of the differences is constant, right? Okay. I think they're asking which of the functions have like a constant difference. And we're supposed to list the function and what difference, which difference is the constant. So like
Okay.
you mentioned quadratic, it's got the constant second difference. Let's see, what's the other one? Yeah, linear has the constant first difference.
So be linear then quadratic.
Yeah, linear with the first difference, and quadratic with the second.
Is there a third?
I don't think so.
Okay. For which function will the ratios of first differences of the data be a constant value? So it's just asking which function of the rate is, which function will the ratios of the first difference be constant, right? It's kind of confusing.
I don't know. I feel like there isn't one.
Yeah.
Maybe the question's just not worded well.
I feel like that's a lot of this course.
Yeah.
Like seriously.
Yeah.
And it's screwing up my grades.
I've got like a 40% right now because we missed the first like 2 of these.
Yeah, I think mine's like 50. But
I get really upset because there aren't like due dates for my math labs.
no, there's not. That's weird.
Yeah.
Like they're not really graded at all.
All right, let's keep going. Number 6. For which functions do the differences exhibit a unique pattern of symmetry? List these functions and describe the symmetry you observe. Differences.
Well, the absolute value in the quadratic would have symmetry, right?
Yeah. But quadratic's got a constant difference. Absolute doesn't. But I feel like it's just absolute.
Yeah.
Kind of goes up and down.
So you think it'd just be the quadratic?
Or just absolute.
Just absolute? Okay.
Okay. Yeah. 7 looks a little easier.
For which functions does the graph both increase and decrease? Linear, right?
Well, it has to be going like up and down.
True.
So like quadratic and absolute.
Yeah.
I think that we just changed the direction one time.
Number 8. Does the graph usually always increase or always decrease?
Let's see. Well, I think like you said for the last one, linear is always it has
It's
to
always
go.
only in one direction, right?
Yeah, it goes up or it goes down.
So that would be linear, right?
Yeah, and I feel like radical is kind of the same way. It's either going up or it's going down.
Yeah. Well, a square. So that one, it looks like it comes up to a certain point and then it just flatlines. That's what it looks.
It keeps going up. It doesn't stop.
Yeah, just slightly.
Yeah.
Okay.
I think this kind of plays in the next one for number 9. For which functions does the graph contain an asymptote? List the functions and whether they have vertical, horizontal, or both types of asymptotes. I kept asking my wife about this one. She yells at me every time because we're not looking at any graphs that have asymptotes right now. So it's I'm not gonna forget that now.
Okay. So did 8 we agree on linear and the radical?
For which one?
Or just one or the other?
Yeah, for 8, yeah, linear and radical.
And about 9?
9 is none because we don't have any graphs with asymptotes.
Okay. 10. Which functions have a domain that does not include all real numbers?
Oh, that's just radical because it just comes out in one direction.
Okay. Which functions are used to model the motion of an object?
radical, what is it, pendulum.
And we also talked about absolute was like the air hockey.
Yeah. It's got a bounce. Quadratic is like a constant acceleration. Linear is a constant velocity.
So should we say absolute and radical?
For which one?
Or is it all four of them?
Well, they're all four. They all do a different thing.
Oh yeah. Okay. Okay, number 12.
All right. Used to model population growth. None of them would do that because we're talking about for population growth. We're talking about like exponential growth.
Yeah.
And we don't have those.
Yeah. Ugh. Okay.
All right.
Anything else we got to do?
All right. So that's the function compare and contrast. Um, we also need to take the practice test. I think just before the next one.
Just before the next video or chat thing?
Yeah, and if we're doing it tomorrow, then yeah, let's just say we'll go over it before we do the next one.
Okay.
So we know that we're all on the same page.
Yeah.
Before we individually take it.
Yeah. And now it's just the two of us, so it's way easier.
Yeah.
Yeah. And we're both real close. I mean, we're both in Idaho Falls.
Do you live with anyone over there?
Just my wife. So cool.
All right. I'll see you tomorrow.
All right, sounds good.
All right, and I'll get this turned in.
All right, sounds good.
All right, we'll see you.
See ya.